Okay. Now, uh, there are two ways to calculate the power. Basically, this is the instantaneous power. This is the power at any instant of time. This is the power at any instant of time. But
Yes.
we want the average power. Basically, for AC circuit, we define the average power because power at each and every instant of time, the power is changing. So, okay, so power is changing. That is why we calculate the average power. So there are two ways to calculate the average power. First way is the integration method. If you want to find the average power, then you have to do like you have calculated the average EMF. Okay, so average power you want to calculate 0 to T, and this is PT and DT, and here is your T. So this is the first method, but this will become very lengthy. This is the first method and this become very lengthy. So we will use a different method here that I have told you. Method second. Okay, method second we will use. So basically this is your first method. Okay, so here is the method second. So I will solve with this method second. Okay. But for that you should know these things. You should know these things. Sine square omega t means average value of sine square omega t for full cycle. We represent, see, average we can represent like we can write P average or we can write P bar. P bar means also the P average. Or if we follow NCRT, then in NCRT average power is written like this. Okay, so there are different ways to write the power. Okay,
Yes.
so I am writing in the form of the bar. So sine omega t, average power of sine omega t, sine omega or average power of the not average power, average value of sine for full cycle is equal to 0. Average value of cos for full cycle is equal to 0. This bar means the average value. Average value of sine square omega t for full cycle is equal to 0
Yeah.
for full cycle. These all values are valid for full cycle. So this thing we should know. And there is one more formula that will be required, that is sine A plus B can be written as sine A cos B plus cos A sine B, cos A sine B. Okay, so now what I am doing, I am calculating the average power. I am calculating the average power. So average of this is the, this is PT and this is the average of this. So this will become whole average. Okay, this will become whole of the average. Okay, so now see this V naught and I naught is constant value. V naught is the peak value of the voltage. I naught is the peak value of the current. If you will take the average of V naught, then it will be V naught. If you will take average of I naught, then it will be I naught because these are the constant values. So we can write average of this is equal to V naught and I naught average and sine omega t average. Okay, and here is sine omega t plus phi average. This average is for full cycle. Now this is V naught into I naught Average of V naught into I naught will be V naught into I naught. Okay. So actually, what we will do here, uh, this is sine omega d, na?
Yes.
Sine omega d. So we will open this formula. We will open this formula. This can be written as sine A plus B.
Yes.
Sine A plus B. So this formula will be used. Sine A plus B. Sine A cos B, cos A sine B. So you can write this as sine A. A means you can take A as omega t. Sine omega t cos phi plus cos omega t sin phi. Okay.
Okay, sir.
Actually, this is the whole. Here will be whole bar. Okay. Here will be whole bar. This is also the whole bar. Means average of whole. Okay. Now see. This is V naught into I naught. V naught into I naught. And now we will multiply this sine omega t with sine omega. This sine omega t
Yes.
multiply with this bracket. So we will multiply this sine omega t with this first. So this will become sine square
Sin.
omega t
Yes.
into cos phi. Okay, this sine omega t into sine omega t, sine square omega t into cos phi. So we can write it as sine square omega t into cos phi. Now
Yes.
sine omega t will be multiplied with this. So this will become sine omega t cos omega t sine phi plus sine omega t cos omega t and sine phi. Sine phi. And here is one. This whole have the average. Okay, so now see. This is V naught into I naught. This is sine square omega t cos phi plus I can write this as half, okay, into
Yes.
2 sine omega t cos omega t, 2 sine omega t cos omega t, and this is sine phi. This is the whole bar. Now 2 sine omega t cos omega t will become sine 2 omega t. This formula you should know. Sine 2a is equal to 2 sine a cos a. So 2 sine omega t cos omega t will become 2 sine 2 omega t. So this will become V naught I naught. This is sine square omega t into cos phi plus this is half multiplied by this is 2 sine omega t cos omega t. It will become sine 2 omega t, and this is sine phi. This is sine phi. Here is this average of whole thing. Now separately we can take the average. Now we can take the average of V naught and I naught. We can write this as this V naught and I naught and bar, and okay, V naught and I naught and bar.
Yeah.
We can take bar of this sine square omega t and cos phi bar on this plus half of this is sine 2 omega t sine phi bar on this whole this. Okay, so var means V naught I naught average. So if you will take the average of this will be
Mm.
remain same. So this will V naught into I naught. Okay. Here you can separate this also. So this will become sine square omega t bar and cos phi bar
Yeah.
plus half, average of half will be half. Okay, average of half will be half. So here your sine 2 omega t bar and sine phi bar. Remember, the average of constant value will remain same. The average of constant value will remain same.
Okay.
And here is phi. Phi is the phase difference. Okay. What is
Okay.
phi? Phi is the phase difference
Yes.
between the voltage and the current. Phi is phase difference between the current and the voltage. So this phi is constant basically. So sine of phi and cos of phi will also be the constant. Now this is V naught and I naught. Now, now this thing will be used. Average of sine square omega t is not 0, is equal to 1 by 2. I have told you. Average of
Yes.
sine square omega t will be 1 by 2.
Yes.
So this will be 1 by 2. And average of cos phi will be cos phi because this is constant quantity. Because phase
Yes.
difference is constant now, so cos phi will be constant. Okay. So plus half now. Average of sine over a full cycle equal to 0. Okay. Average of average of sine of any angle
Yes.
for full cycle equal to 0. If I have written here sine of 2 omega t, if I have
Yeah.
written like this, sine of 2 omega t average,
Yes.
that is also equal to 0.
Okay.
So here average of this equal to 0 and average of sine phi will be sine phi because sine phi is the constant.
Yeah.
Now average power, this pt bar can be written as average power. So average power will equal to V naught I naught. This is V naught. This is I naught. This is half of cos phi. And this is 0. So average power you will get in AC, that is V naught I naught by 2 into cos phi. V naught I naught by 2 into cos phi. So this is the first formula. We can change this formula into the root mean square values. Okay.
Okay.
So VRMS is equal to V naught by root 2. We know that. And IRMS is equal to I naught by root 2. So put the value of V naught and I naught. Oh. Just a minute, just a minute. Okay, so from here we can write the value of V naught. We can write the value of V naught. So V naught will be root 2 times of VRMS. V naught will be root 2 times of VRMS. This will be root 2 times of VRMS. And I naught is root 2 times of IRMS
Yeah. Okay.
into cos phi and divided by 2.
Okay.
Okay.
Yeah. Yes.
This root 2 and root 2 multiplied become 2
Two.
and
Yes.
2 and 2 will be cancelled out. So
Yeah.
finally we will get average power as VRMS IRMS cos phi. This is the formula in terms of RMS values. And this cos phi is known as the power factor. Is known as the power factor.
Perfect. Yeah.
Okay, take the screenshots.
Done, sir. Done, sir. Done, sir.
Okay. So now we will discuss on power factor. We will discuss on power factor. Power factor. What is power factor? Cos phi. And what is phi? Phi is the phase difference between the current and voltage. Phase difference between the current and voltage. So if I am talking about for first type of circuit that we have discussed, pure resistive circuit. Pure resistive circuit. In pure resistive circuit, what is the phase difference between the current and the voltage? What is the phase difference between the current and the voltage?
So pure resistive?
Pure resistive means if only resistance is connected with an alternating source. What is the phase difference? 0 degree, na? Voltage and current are in same phase.
Yeah.
Okay, voltage and current are in same phase. So here phi value is 0. So power factor, that is cos phi, is cos 0 and cos 0 is 1. So power factor for the pure resistive circuit is equal to 1. Power factor is equal to 1 for pure resistive circuit. Okay,
Yeah.
now purely inductive circuit.
Purely inductive.
What is the phase difference between the current and the voltage in purely inductive circuit? I have told you, na, in
Omega T.
inductive circuit, the voltage leads the current by pi by
Yeah.
2.
Yeah. So
So
pure
phase,
inductive.
yeah,
It
pure
lags
inductive
behind
circuit.
it. It
No,
lags
no,
behind.
no, no, no. Current lags, na. In inductive circuit, current lags, but voltage leads.
Yeah.
By 90 degree. By 90 degree. We have discussed this many times. So what is the value of phi? Phi here is 90 degree. So what is the power factor? That is cos phi. Cos 90 degree. Cos 90 is equal to 0. So
Yes.
power factor in case of pure inductive circuit is equal to 0. Purely capacitive circuit, what is the phase difference?
It lags, right?
Yeah, you are right, lags. I mean, which one left? Current or voltage?
Current.
No, voltage lags. This time voltage lags. Current leads by 90 degree. So phase difference here also 90 degree. So power factor again is equal to cos 90. Cos 90 is equal to 0. Cos 90 is equal to 0.
Yeah.
Okay. Fourth circuit that I have discussed, LCR circuit. Basically, this is first, second, and this is third. LCR series circuit. LCR circuit. In LCR circuit, now we want the cos phi. We want the cos phi in LCR circuit. And for that, in LCR circuit, what type of phasor diagram will be there? We should know. What type of phasor diagram there? So in LCR circuit, what happens? Basically, take one case. Take one case. If you can say that your XL is greater than XC, then your diagram will be like this. This will be your XL minus XC.
Yeah.
Okay. And here is your resistance. And resultant of this will be the impedance Z. And this is the phi.
Yeah.
Yesterday, you were talking about the impedance triangle. So
Yes.
basically, here a triangle will be there. Na?
Yes.
How the triangle will be there? See how the triangle will be there. This is the Z. This is Z. And if I draw this like this, okay, if I draw this like this means what I am doing here, I am just drawing a parallel line, okay. Parallel line means a line which is parallel to this line. So
Yeah.
I am drawing like this. It will be like this, and from here there will be a parallel line, and at the point at which both the parallel line will intersect will be the head of the this arrow, and this length of the arrow is Z.
Yeah.
Remember, length of the arrow is Z. Okay, length of the arrow is Z. So Z is the length of the arrow. So we will draw the triangle separately. Okay. So here I am drawing the triangle again. So basically this is the triangle you will get. This is Z. Okay, this angle is phi. This is R, and this length will become XL minus XC. Why this length become XL minus XC? There is a reason. XL minus XC. Why this becomes equal? Because you are drawing a line, this which is parallel to this line, means
Yes.
this line, length of this line will be equal to length of this line.
Yes.
Okay, now you are drawing a line which is parallel to this line, that is this line, means length of
Yeah.
this line will be equal to this line, and length
Yes.
of this line will be XL minus XC. That is why this is XL minus XC, and this is known as the impedance triangle. So now from here, if you want to find the cos phi, that is power factor. Power factor, if you want to find, that is cos phi. Okay. So cos is base divided by hypotenuse. Base is R. Base is R. This is a right angle triangle. Na? Base is R. And
Yeah.
hypotenuse is Z. So basically in series LCR circuit, the power factor is given by R by Z. Power factor is given by R by Z. Yesterday also I think I have told you this thing in this question. Power factor 9th part. I have told you that we will discuss it
Yeah.
later. Cos
Yes.
phi. Okay. So there we have calculated the cos phi with the help of this triangle. Okay. There also I have written perpendicular base divided by hypotenuse. Base divided by hypotenuse means resistance divided by impedance. Okay. So phasor diagram should be clear to you. Okay. Phasor diagram should be clear to you. So this is the case I have taken. XL is greater than XC. You can take another case in which XC can be greater than XL. Then there are slight changes in the phasor diagram. There are slight changes in the phasor diagram. Okay. So there are a few note points. Number one, if not mentioned, if not mentioned, then assume average power. Ziayd, we will wait for Azan for
Okay.
2 minutes. Okay.
Okay.
Okay. So if somewhere the power is given and circuit will be AC, then what you will assume? Average power. Here also I have calculated the average power because in AC circuit we are interested in average power, and this is a sign of average. This is a sign of average. Okay. So here I think I have told you na how to denote the average. We denote average like this also, or we denote the average like this also, or we can just simply write P average. Okay. So this thing keep in mind.
Okay.
So if not mentioned, then we will assume the average power. Another point, if not mentioned, then we will assume RMS, root mean square current, and root mean square voltage if not given. So you can now modify this formula of power. Power is given by VRMS, IRMS, cos phi na. So
Yeah.
you can write average power as VRMS, IRMS. Instead of cos phi, you can write RYZ. You can write RYZ. Okay.
Okay.
So this will be the power in the AC circuit. Okay. So accordingly, you will use the formula accordingly. Basically, I am just driving these all these formula. I have derived this formula from this. Okay.
Okay.
And this formula from this. Okay. So note down.
Done, sir. Done, sir. Done.
Okay. And remember, this derivation is very, very important. Okay, this had appeared in your board many times. Okay, so this derivation is very important. Okay, so now this is all about the power. What is the formula of the power? In terms of the peak voltage you can write, or in terms of the RMS voltage or RMS current you can write VRMS IRMS cos phi. What is cos phi? Cos phi is power factor. Power factor is given by R by Z. And average, sometimes we do not like this, sometimes we do not like this, and we can simply write P average.
Okay.
So now we will discuss the resonance. We will discuss the resonance. Okay, so this here is some resistance, and here is the capacitor, here is the inductor in this circuit, and this is the voltage and this is the current. This is the current and this is the voltage. And phi is the phase difference between the current and the voltage. Phi is the phase difference between the current and the voltage. So we have discussed earlier, how to draw the phasor diagram.
Yeah.
Resistance will be in this direction like this,
Yeah.
and here will be your XL, and here will be your XC, because this is your current. Current will be in this direction. Okay. In terms of voltage, if you want to draw, then it will be peak voltage across the resistance. Here will be peak voltage across the inductor. Here will be peak voltage across the capacitor. So we have discussed three cases. Basically, this is the phasor diagram.
Yeah.
Phasor diagram. We have discussed three cases. Number one, we have discussed XL can be greater than XC, then what will happen? What type of phasor diagram will be there? I have discussed now. Secondly, I have discussed
Yes.
when XL will be less than XC, then what will be the phasor diagram and what will be the condition? Third case I have discussed, I have told you in the last class, third case, when your XL is equal to XC, I have told you this is the case we will discuss later, and this is the condition of resonance. This is the condition of
Resonance.
resonance. Condition of resonance. So in LCR series circuit, when XL is equal to XC, XL means inductive reactance becomes equal to the capacitive reactance, then resonance occur in the LCR circuit. What is the meaning of the resonance? We will see. Okay, so at resonance, what happens? At resonance, what happens? XL becomes equal to XC. What is XL? XL is given by omega L.
Yeah. Yeah.
Omega will be same because you are supplying the voltage. This voltage you are supplying. So this is the angular frequency. So angular frequency throughout the circuit is same.
Yes.
Okay. So omega L. And what is XC? XC is 1 upon omega C. Now when you will multiply, you will get omega square is equal to 1 by LC. And omega you will get 1 upon under root LC. This will be your angular frequency. This will be your angular frequency at resonance. This will be your angular frequency at resonance. So I am saying this frequency as omega naught is equal to 1 upon under root LC. What is omega naught? Angular frequency, or you can say resonant frequency. Resonant angular frequency. This is the frequency. This is the frequency at which resonance occurs. Resonant angular frequency. Resonant angular frequency. One more thing I have told you. What is L? L is the inductance. What is C? C is the capacitance.
Capacitance. Yeah.
Told you, na? There is a relation between omega and the frequency 2 pi f. So here will be resonant frequency, resonant angular frequency. So here will be resonant frequency only. So f naught, if you want to find, you can write omega by 2 pi. So from here you will get f naught 1 upon 2 pi. What is omega? This is 1 by LC. So you can write 1 upon 2 pi under root 1 upon LC. So this is the resonant frequency. This is the resonant frequency. Okay. So basically, this is the formulas for the frequency. Formulas for the frequency. What we are calculating here? Frequency. Frequency. Now we will see what will be the impedance of the circuit. What impedance?
Yeah.
Impedance means Z. Impedance of the circuit, we will see what is the value of the impedance. What is the formula of the impedance? For the series LCR circuit, under root of R square plus XL minus XC square. At resonance, I have told you XL becomes equal to XC. So this term will become 0.
Yeah.
This is R square. Here your XL is equal to XC. So
Yes.
XL minus XC will become 0 now.
Yeah.
So Z will be under root of R square, means Z is equal to RC. This will be your impedance of the circuit. Basically, impedance of the circuit is equal to the resistance of the circuit this time. Impedance of the circuit is equal to the resistance of the circuit. And see this. This Z will be the minimum. This Z will be the minimum. This is the minimum impedance of the circuit. This will be the minimum impedance of the circuit.
Yeah.
Why minimum? Why minimum? Because you can see here, this value becomes 0.
Yeah.
So this Z become minimum. Earlier, this has some value. Means you are
Yes.
adding something in R, and you are getting more value. Now this thing becomes 0.
Yes.
So if this thing becomes 0, then here is only R. So means you can say that Z becomes minimum. So this is the minimum value of impedance, minimum value. So if the impedance of the circuit becomes minimum, then current become maximum. Then current will become maximum. Now you can write formula for the current. So current is equal to, what is current in the circuit? I naught is equal to V naught by Z. I naught is equal to V naught by Z now. So
Yeah.
this I naught will become the maximum current when Z becomes R. Z becomes R. This will be the value of the maximum current. So this current will be maximum. Current will be maximum. One more thing. One more thing. If you want to calculate the power factor, see, if you want to calculate the power factor, what is power factor? Cos phi. Remember, na?
Yes.
What is power factor for this resonance condition? Means for each and every condition, I am not saying for specifically for resonance condition, power factor is cos phi. So if you want to calculate cos phi, what is the formula for calculating cos phi? R by Z, was this time your Z is equal to R. Okay, so this is your cos phi, and this is R, and Z also R. Z is also R, so this is become 1.
So
So
1.
cos phi is equal to 1.
Yes.
So you can say phi is equal to 0 degree. So remember this point also. At resonance, the phase difference between the current and the voltage is equal to 0 degree. So here this phi is equal to 0. This phi is equal to
So
0
only at
degree.
resonance.
Yeah, phi is at only at resonance.
Okay.
Not only at resonance. See, what I want to say, phi can be 0 also at
Okay.
any other case. Like in case of the purely resistive circuit, in case of the purely resistive circuit, we have seen that the current and the voltages are in same phase now. Then
Yes.
also the phi is equal to 0. But here also the phi is equal to 0. So when you will put phi is equal to 0 here, you will get only omega t. Okay. So this phase
Okay.
difference phi is equal to 0. So now equation of the current and the voltage will be, equation of the voltage will be V is equal to V naught sine omega t, and equation of the current is equal to I is equal to I naught sine omega t. I is equal to I naught sine omega t. Now there is one more term that we have calculated there. One more term that we have calculated there, tan phi. What is the formula of tan phi? XL minus XC divided by R. Now at resonance, your XL is equal to XC. Your XL is equal to XC. So this thing becomes 0. Tan phi becomes 0. So from here also you can calculate the phase difference. Phase difference is equal to 0 degree. And what is phi? Phi is the phase difference. 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 So at resonance you can write the current become maximum and the impedance of the circuit becomes minimum. So at resonance, the impedance becomes minimum and current becomes maximum. Current becomes maximum. Okay, so write down.
Done. Yes. Done, sir.
Now we will see what will be the power at resonance. What will be the power at resonance? power at resonance. Power at resonance. So what is the formula for the power for LCR circuit? Just drive
Next.
average power we calculate. VRMS, IRMS cos phi. VRMS,
Yeah. I know.
IRMS cos phi. Tell me at resonance, what is phi?
At phase angle. Right?
Yeah, phi. Zero, na?
Yes.
So put 0 here. So average power is equal to VRMS I RMS cos 0,
Cause
and cos 0 degree is equal to 1.
yes.
So this will become only VRMS into IRMS. VRMS into IRMS. And this power will also be the maximum power. Okay. This power will be the maximum power.
Hmm.
Okay. Here cos phi is equal to 1 means cos 1 is the maximum value of the cos. So cos becomes maximum. So we can say power becomes maximum. So this average power is basically the maximum average power. So this average power becomes maximum. Now there are some graphs, the graphs that we will discuss here. Okay. Have you completed this part? I think completed, na? Ziayd,
Yes, it is. No.
completed, na? Okay, so take the screenshot of this also, then we will discuss the graphs.
Okay. Done. Sir.
Okay. Okay, so we will draw the graph impedance versus frequency. This is your frequency on this axis, and here will be your XC, and here will be your XL, and here will be your resistance. XC, XL, and resistance. So I have told you the graph between XC and frequency. What is XC? XC is equal to omega C,
Yes.
and omega is 2 pi f into C. 2 pi is constant, C is constant. So you can say that XC is given by 1 by omega C, and omega can be written as 2 pi into fc. So your XC is inversely proportional to frequency. So graph will be like this. Graph of XC versus, this is XC. Graph of XC versus frequency will be like this. And I have told you that what is XL? XL is equal to omega L. So you can write 2 pi f into L. So you can say your XL is directly proportional to frequency. So graph of this will be like this.
Yes.
This will be the straight line. This will be the straight line.
Great.
straight line graph. And the point where both becomes equal, XC and XL becomes equal, is the condition of resonance. And at
Yes.
this point, your XL is equal to XC, and this is the frequency. What type of frequency? Resonant frequency.
Yeah.
This is the resonant frequency. And if you will talk about the resistance, so resistance of the circuit remains constant, means does not change with respect to frequency. So you can say resistance will be like this. So resistance will be like this. So this is the graph for the XL. This is for resistance. This is the first graph. Now we will discuss the graph of impedance versus frequency. Impedance versus frequency. This is the first graph. Second graph is Z is the impedance I have told you versus frequency we will discuss.
Yes.
Okay. So first, okay, now impedance is given by under root of R square plus XL minus XC square. Okay. So now we can write this as R square plus what is XL? Means XL is omega L,
Yes.
XC is 1 upon omega C,
Yes.
and a square of this. Okay, so omega is given by, this is R square plus, you can write omega as 2 pi into F into L minus 1 upon 2 pi F into C, and a square of this. If you take any small value of F, if you will take any small value of L, if you will take a small frequency, if you will take a small frequency,
Yeah.
so this term will be small, this term will be small, and this whole term will be large. So a small minus large will become something. Okay,
Yes.
will become something.
Yeah.
Okay, yeah. Okay, Z becomes large. Why Z becomes large? Because something will be added to the resistance. Something will be added to the resistance. If you
Yes.
will take large value of frequency, large value of the frequency, then what will happen? This will become large, this will become large, and this will become small. So large minus small and square of that, and you are adding with this resistance, that whole thing will become large. So this, in this case also, Z is large. When the frequency becomes the resonant frequency, so Z becomes R, and that Z will be the minimum, and that Z will be the minimum. So basically the graph will be like this. Graph will be like this. Like this. Okay. So here will be a point where impedance of the circuit will be minimum. That will be R. Here that becomes R, and this will be resonant frequency. This is the graph. Okay. So here your Z is large. Okay,
Yes.
Z is large. Then frequency is small. If you are taking a small frequency, then also your Z is large. If you are taking higher frequency, then also your Z is large. But at a certain frequency, resonant frequency, your Z will be minimum. So this will be the minimum value of the Z, and that is equal to the resistance. Okay.
Yeah.
One more graph. This time we will draw the graph between the current and the frequency. Current and frequency. frequency. Current versus frequency. Okay, so basically, current in the circuit is given by I naught is equal to V naught by Z. So current is inversely proportional to Z, na? So if you will draw the graph between current and Z, this graph is like this. This graph is like this, na? So this the graph between the current and Z will be opposite to this. Will be like this. Okay, will be like this. Here will be some point at which the current will be maximum. This will be frequency. So this will be resonant frequency F naught, and this will be I max. Not I max, that current, maximum current. So maximum current is given by V naught by Z.
Yes.
V naught by Z, and what is Z at resonance? R. V naught by R. You can write this. So there is one more graph. If you want to draw a graph between the average power and the frequency. So another graph number 4. Graph between the average power versus frequency. So this will be also like this, because maximum power is given by VRMS into IRMS into cos phi, and this can be modified to I naught square max into R by 2. Okay. So means power is directly proportional to current. So graph of power and current will be same. This will be like this. So here will be the maximum power, and corresponding to this, the frequency will be the resonant frequency. Should I prove this now? Or you can do this by yourself. Means how this comes, this thing. If you are confused, then I can prove.
Yeah, okay, so you can prove.
Okay. VRMS can be written as, we know that the current in the circuit is given by V naught by Z. Okay, V naught by Z, and one relation you should know. V naught is equal to root 2 times of VRMS, and I naught is equal to root 2 times of IRMS. Now put the value of I naught and V naught here. Put the value of I naught. What is I naught? Root 2 times of IRMS. V naught root 2 times of VRMS divided by Z, and at resonance, and this root 2 and root 2 will be cancel out. So IRMS can be written as VRMS by Z. We can write this. Okay. Now see this. So from here we can write VRMS is equal to IRMS, okay, into Z.
Okay.
Now VRMS can be written as IRMS into Z. Here IRMS into Z, and this is also IRMS. And cos phi is equal to R by Z. Cos phi is equal to R by Z.
Yeah.
Okay.
Yes.
Okay. Now this is IRMS square. Z and Z will be cancelled out into R. So this is the maximum power. If you want to write this in terms of peak value, then you can write, you know that IRMS also can be written as I naught by root 2. When you will put, you will get I naught max by root 2. Because this thing I am driving for the condition of resonance. Okay. So I naught maximum by 2 into R. So basically all these things we are doing at resonance. Okay. So write down.
Answer.
Done. Okay.
Yes. Answer. Answer. Don't. Don't.
Okay. So there is one more topic. That is quality factor. Quality factor. So quality factor is also, we write Q factor, and this Q factor is given by omega naught divided by delta W. What is omega naught? I have told you, resonant frequency. Omega naught is the resonant frequency.
Yes.
Okay, before that, there is one more topic. Before that, sorry. Basically, there is a graph first. We'll draw. Write the heading sharpness sharpness of resonance and bandwidth. Sharpness of resonant and bandwidth. Okay, so I will explain this with the help of this graph. So this is a graph between the current and omega. If you will draw, graph will be same now, because we know that omega is given by 2 pi f. Okay, so omega is directly proportional to f. So here we can write omega also. Okay, so here what is the value of the current? If this is omega naught, this is I naught. I naught max, peak value of the current. There is one more value of the current somewhere here, and that value is I naught max by root 2. I naught max by. For this, there are particular frequency corresponding to this. Suppose this is your omega 1 and this is your omega 2. Omega 2. And this omega 1 and omega 2 are known as the half power frequency. Omega 1 and omega 2 known as the half power frequency. Half power frequency. Okay. Now there is a term bandwidth. So basically bandwidth is given by delta W. Delta W is bandwidth, and this is given by omega 2 minus omega 1. Okay, this is omega 2, this is omega 1.
Yeah.
And this is given by R by L. This is given by R by L. So actually we want a small bandwidth. Okay, we want, remember this point, small bandwidth. So for a small bandwidth, your resistance should be small. Your resistance should be small.
Yes.
Okay.
Okay.
So resistance should be small. Okay. So this omega 1 can be written as, this is omega 1 na? This from here to here, this is omega 1. From here to here, this is omega 2. So omega 1 can be written as, this value is omega naught. Okay, this value is omega naught. What is omega, delta omega? Delta omega is R by L. Delta
Yeah.
omega means this distance is R by L.
Okay.
Okay, this C, this distance is R by L. This distance is R by L. So this distance will be R by 2L. Also, this distance will be R by 2L. Is it or not?
Yes.
Bandwidth is R by L. So this distance will be half of the R by L, means half. R by 2L. This is also R by 2L. Now we can write what is omega 1. Omega 1 we can write omega minus R by L. This is omega minus R by L becomes omega L. So omega 1 is equal to omega naught minus R by not L, R by 2L. And omega 2 you can write omega naught plus R by 2L. See this here. This distance is omega naught and this distance is R by 2L. So whole distance is omega 2. So omega 2 can be written like this. Now we can write what is quality factor. Quality factor. So quality factor is, we can write Q factor is given by omega naught divided by delta omega. What is delta omega? Bandwidth. What is delta omega? Bandwidth. And what is omega naught? Omega naught is given by 1 upon under root LC. And what is delta omega? R by L. Put the value here. Omega naught 1 upon under root LC. And delta W is equal to R by L. Finally, you will get 1 upon R under root L by C. So this is your Q factor. What is R? Resistance. What is L? Inductance. What is C? Capacitance. So this is your Q factor. Okay, note down. One last topic is left it, that is transformer.
Done, sir. Done, sir.
This is your transformer. Basically, transformer is a device. Transformer is a device that transforms the voltage. Transforming voltage means it can change higher voltage to lower voltage. It can change lower voltage to higher voltage. See here, a device that transforms voltage is transformer. It can convert low voltage to high voltage. It can convert high voltage to low voltage. A transformer which transform low voltage to high voltage is known as the step up transformer. Step up transformer. A transformer which transform high voltage to low voltage is known as the step down transformer. What is the principle on which the transformer is based? Principle of mutual induction. Can you tell me what is mutual induction? Mutual induction. Earlier we have taken two coils in electromagnetic induction. I have told you there is a change in one coil, change in current in one coil, then in another coil there will be induced current. That is known as the mutual induction. Okay.
Yes.
Mutual induction is basically the property of two coils. When you change the current in one coil, there is an induced current in another coil, or you can say there is an induced EMF in another coil. See what happens there. You have a coil, you have two coils, and I have to go here to EMI for the mutual induction. This is one coil, this is another coil.
Yes.
Okay, this is connected with battery. So here current is increasing in this coil. Suddenly you have connected this coil with battery, coil number 1. Current will start increasing. So here, due to the current, due to this coil, there will be the magnetic field.
Yeah.
The effect of this magnetic field will be here also at the coil number 2. So when the current increase, you can say here the magnetic field will increase. Due to increase in the magnetic field, there will be increase in the magnetic flux. And what happens when there is an increase in magnetic flux? EMF induced in the coil. So here in coil number 2, EMF will be induced. Okay?
Yes. Okay.
EMF will be, and due to that induced EMF, there will be the induced current. That is why this galvanometer has some deflection. Okay, so before starting the transformer, you should know some basic things. Means you should know what is the formula of the flux. That is VA cos theta. V is the magnetic
Yeah.
field, A is the area, theta is the angle between the magnetic field and the area vector. This is a solenoid. What is this? This is a solenoid.
So yeah.
Solenoid have the magnetic field along the axis only. We consider for a solenoid magnetic field basically along the axis. Okay, and the
Yeah.
magnetic field for the solenoid is given by mu naught Ni. What is mu naught? Mu naught is the permeability of the free space and
Yes.
number of turns in solenoid. I
Yes.
is the current in the solenoid. So in the next class we will discuss the transformer. In the next class we will discuss the transformer. Okay.
Okay.
Okay. So Ziayd, can you tell me what is the phase difference between the current and the voltage in purely resistive circuit?
So can you repeat?
I am saying what is the phase difference between the current and the voltage in purely resistive circuit?
In purely resistive,
Hmm.
I is equal to I naught sin omega
Hmm.
t.
I is equal to I naught sin omega t. I'm just asking the phase difference. Phase difference means difference of phase between the
Oh,
current
okay.
and the voltage.
It's
0 degree.
0 degree. Yeah.
What is the phase difference between the current and the voltage in purely capacitive circuit?
Purely capacitor 90 degree.
And what is the phase difference? Right. What is the phase difference between the and tell me in inductive circuit, in purely inductive circuit, current leads or the voltage leads?
In inductive, purely inductive,
Hmm.
the voltage leads, right?
By what angle?
By 90 degree.
What is the formula of the average power in a AC circuit?
Average.
What is the formula of the power in AC circuit? Power in AC circuit is given by this. Told you, na? VRMS, IRMS, cos phi. What is phi here? What is phi? Phase difference.
Phase
Okay,
difference.
and remember this also. VRMS is equal to V naught by